Earth's amazing time capsules. Have you ever wondered what lived on our Earth a super long time ago? These amazing clues are called fossils. They are like secret messages from the past just waiting to be discovered by curious explorers like you. Fossils can tell us stories about giant dinosaurs, strange sea creatures, and plants that looked very different from the ones we see in our gardens today. So what exactly is a fossil? Well, a fossil is the preserved remains, or traces, of ancient living things. That means they could be the actual bits of an animal, like its bones or teeth, or even a plant's leaves or wood. Sometimes they can be things like footprints left in mud that later turned to stone, or even the shape of a shell. These amazing remnants have been saved in the Earth's crust for thousands or even millions of years. Imagine something lasting that long. It's truly incredible to think about. People who look for fossils, called paleontologists, dig them up from cliffs, quarries, and even deserts. Each fossil, big or small, has a unique story to tell about the history of life on our planet. The super story of sediment. So, how does an ancient plant or animal actually turn into one of these amazing rock treasures? It all starts when a living thing, perhaps a giant fern or a swimming ammonite, dies. If it's lucky, it might fall into water like a river, lake, or the sea. The important thing is that it gets buried, and quickly too. This is the very first step in its long journey to becoming a fossil. Once the plant or animal is buried, tiny bits of rock, sand, and mud, called sediment, start to pile up on top of it. Over thousands and millions of years, more and more sediment builds up. This creates a lot of weight and pressure, squashing the layers underneath. The water that seeps through these layers is also very important. It carries tiny minerals with it, which will play a big part in the fossil-making magic later on. As the layers of sediment get thicker and heavier, they start to turn into rock. This process is called lithification. That's a fancy word for rock making. The pressure squeezes out the water, and the minerals in the water can act like cement, sticking the sediment grains together. So the animal or plant remains are now trapped inside this newly formed sedimentary rock. This is why most fossils are found in sedimentary rocks like sandstone, limestone, or shale. Now the really interesting part begins: fossilization. The soft parts of the animal, like its skin or muscles, usually rot away quite quickly, even if it's buried. That's why we often find fossils of hard parts like bones, teeth, shells, or the woody parts of plants. A treasure trove of shapes. Not all fossils are the same. Just like there are many different kinds of animals and plants, there are also different kinds of fossils. One common type is called a mold fossil. This happens when an animal or plant gets buried in sediment, and then its body slowly rots or dissolves away completely. What's left behind is an empty space in the rock that is the exact shape of the creature or plant. Then we have something called a cast fossil. Imagine that empty mold fossil we just talked about. If water full of dissolved minerals seeps into that empty space, the minerals can slowly build up inside the mold. Over a very long time, these minerals harden and fill up the entire space, creating a solid copy of the original organism. Another exciting type of fossil is a trace fossil. These aren't parts of the animal or plant itself, but they show us evidence that they were there. Trace fossils can be things like footprints left by a dinosaur walking in mud, or burrows where ancient worms or animals lived. They can even be fossilized poo, which scientists call coprolites. These might sound a bit yucky, but they can tell paleontologists a lot about what ancient animals ate and how they behaved. Finally, there are true form fossils, also sometimes called body fossils when they preserve the actual organism. These are the rarest and often the most amazing. This is where most of the original creature, or a very large part of it, has been preserved. Think of insects perfectly trapped in sticky tree resin that hardened into amber. The amber protects the insect from decay for millions of years. Sometimes animals have been found frozen in ice, like woolly mammoths, with their skin, fur, and even muscles still intact. Section 4. The magic changes how fossils really form. Fossilization isn't just about being buried and squashed. It involves some really cool changes, both physical and chemical. When an animal or plant gets covered by layers of sediment, it gets pressed down. Think about what happens if you put a big pile of books on top of a squishy toy. It gets flattened. The immense pressure compacts the sediment and the remains within it. This pressure also helps to squeeze out water, turning sediment into rock. Chemical changes like permineralization and replacement are key. Groundwater seeps into bones, crystallizing minerals in tiny spaces. Sometimes original material is replaced molecule by molecule. Fossils retain their shape but are made of new minerals. Petrified wood is a great example of this process. That's why the fossil record is full of bones, teeth, and shells. Under rare conditions, even soft tissues can fossilize, giving us glimpses of ancient creatures. Fossilization is a delicate balance of the right conditions, materials, and millions of years. Section 5. Why fossils are super important. Fossils are like history books written in stone. They reveal what life was like millions of years ago. Paleontologists use fossils to piece together Earth's past. Without fossils, we'd know little about dinosaurs and ancient creatures. Fossils also show how Earth and its climate have changed. They connect us to a deep, ancient past. Who knows what amazing fossil discoveries await?